The panel is called How Nature Inspires Us to Build New Materials. So in order to warm you all up, I'm going to turn this on its head. Why nature? I mean, in a different panel, in a different conference perhaps, I might go to a talk about metamaterials, right? We make things that have never been seen in nature that have amazing properties, and we should, improve upon what nature has done or do something entirely different altogether. In short, maybe a bit from each of you, why nature? Why should we bother?
So a lot of people have written about how nanotechnology is going to transform the future. And by definition, nature is a molecular assembler. It is nanotechnology, and it happens to be toxin-free, compatible with the planet, and easily available. So that's why I think nature.
Okay. So I would think about it in terms of compute.
In terms of?
Compute. So if you think about the search space for stuff in this universe, vast. So vast we can't make enough atoms, we don't have enough atoms to make all the things that we could make, even by a stretch of the imagination. So what we do, we think about 10 to the 175 different polymers we could make, only 10 to the 90 atoms in the universe to make it. 4 billion years of evolution in this planet is the biggest compute anyone's ever run to go find things, so why not use it? It's bigger than anything we could imagine building a computer to compute, so.
Okay. Silvia?
I kind of have a little bit of a different opinion on this, because I think nature should serve as this inspiration also for processes. So you don't have to compare necessarily artificial from natural. There are some algorithm or artificial intelligence that maybe also can overcome and do faster what nature experienced with evolution. So it's something that doesn't necessarily need to be in contrast. But somehow sometimes it's easier to take inspiration from what nature produces in terms of processes, or just also loop, and then exploit this knowledge to fabricate or make new materials, or also using directly natural materials.
Well, I mean, one of the sort of touted benefits is about sort of biodegradability, for example. I mean, who's to say if you're inspired by natural materials, or if you make a spider silk that has sort of a slightly different sequence, so you optimize for a particular material, that you're going to get all of those same benefits, that you're going to get your biodegradability. Couldn't you sort of accidentally make something that's just as bad as the microfibers we heard about, for example?
You can test around that pretty easily. So when we talk about biodegradability, it's the difference between aliphatic carbon-carbon bonds and peptide bonds, which makes that all of life has evolved proteases and things to break up proteinaceous materials, which is why we know that from the get-go that you've got something that's going to be fine. Life has been evolving proteins for forever. And being able to break them up back into amino acids and turn them back into new proteins in every cell in every organism on the planet. So unlikely, but that's why we test.
So in a sense, it's not so much biomimetic materials as new ways. It's all protein-based. Do you guys see this as an entirely sort of protein engineering effort?
For us, yes. I suspect not for other folks. When you're growing whole organisms and things like that to make the materials. Mm-hmm. But yeah, I mean, there's the search space for things that life makes on this planet is giant, and it's a big opportunity space.
Well, let me just touch on that, because I mean, I think the exciting and really the field that's suddenly become accessible in the field that you've been helping drive, which is taking protein engineering and using it to make really amazing materials, is where we're starting to see some of these big innovations. But it doesn't have to be proteins. There's a company, Biomason, run by Ginger Dossier out of North Carolina, and they use bacteria to grow bricks. The bacteria actually precipitate a reaction that causes calcium to form in between the sand interstices and creates a very strong material with no CO2 emissions, much like cement. So there's no real protein engineering going on there other than in the cell wall of the bacteria, but you're still getting a biologically based material, which is sort of on the threshold of being bio-inspired and actually biologically derived.
And if I may add, if you want, within the knowledge in terms of protein advanced incredibly in the last 10 years. So that's also why we can see an exploit of all these different materials that are mainly protein-based. But there are a lot of other materials like that we also are used in industry, like as you were saying, cellulose and plants and general polysaccharides, where the knowledge, the understanding of the material itself, it's still not as advanced as we think. So how polysaccharides interact in the plant cell wall it's really a hot topic in science now. So, and obviously the lack of control from the understanding of the fundamental point of view, maybe also it's impedes the advance of creating new material in terms of for industry. So there is still a lot of work to do, I think, also in this type of context. So I think proteins, they are getting more advanced also because there has been a really strong scientific push into this field, also for not only for material but also for medicines, personalized medicines. So this understanding, it's really big. And other type of material like polysaccharides, biopolymer, chitin, the understanding of the interaction of these polysaccharides with the other proteins or other polysaccharides is still a lot of work to do.
And a real sort of continuum of potential applications, but we have to stick to materials, right? No medicine yet. I'll continue to provoke you by pointing out, I mean, I've been reporting on science for a long time, and I have, seen and myself used the word biomimetic over and over again, and still there's no like giant breakout company. There is still no kind of like vast success story of sort of earth-shattering thing so that everyone knows, we still tell audiences what the merits of this approach are. Why do you suppose there isn't a Facebook of biomimetic materials?
Velcro.
Where's the nylon?
Velcro. Velcro is an example of biomimetic material. It's used everywhere on many different type of structures. So you don't think that you are actually using a biomimetic material, but Velcro it is. So super hydrophobic coating that, for example, are on many of the pans that you use in the kitchen. That's, if you want, many of the structure are inspired to the one that you have in lotus leaf. So they are there, and maybe is they are not produced with natural material yet, but there are already commercially relevant.
Well, I guess that's the distinction between making something with some other material that looks like nature and making it from nature.
So I think that's where we get into a little bit of trouble with biomimicry, is oftentimes when we talk about biomimicry, we've often talked about looking at biology for inspiration, then take the materials we know to engineer and build a product from them. And those feel to me very solution-oriented to specific case studies. To get something that is a platform-based technology company that really is a massive success story we all talk about, it's probably something that has to be more platform in nature than very individualized solution-based. And that's where I think about this next generation of companies you see coming along, represented by folks on the stage and a number of others out there, which is still in its infancy. It's not so much biomimicry as take the performance materials from nature and bring them straight out to the consumer. And I think that there it's just that the underlying technology is too early in terms of what's needed. I've told a lot of entrepreneurs recently who are starting these companies, we all start them as scientists, naively thinking the science is the hardest part. It's very self-serving. It is the hardest part until you fix it, and then you realize that the scale-up is harder. And that's what's been stopping. I mean, Eben, you probably experienced this, that like, hey, it worked in the lab. That tells you very little compared to when it actually works and you're producing a product at some sort of reasonable scale. But it's coming, and the day will come, I think. If I was to bet on a field for the next 50 years, I'd put my money in and then walk away and come back, it would be in biology.
Let me answer that one other way, which I think you hit on the nub, which is the distinction between being inspired by nature and replicating those designs with chemistry, conventional chemistry or otherwise, or mechanically. Velcro is the example to your question, which is spot on. But this ability to actually take from nature, take a compound from nature or a property from nature and engineer it into a product is just happening. I mean, your company is like just getting commercial there. My company has just become commercial. We just got the tools to program biology. But you want an example of a company that's done this? It's worth hundreds of billions of dollars?
Go on.
Monsanto. Now, no one wants to hear that, right? No one wants to hear GMO food on stage. Yeah, let's hear the booze. And I would agree with you. I don't think we should engineer crops to put more nasty chemicals on them, but they have been basically taking what we did with domestication, which is how we captured corn and made it a food source, and pushed that to the limit. And they've just done it in this little slice of our economy. So when you see that slide over into materials, I think you will see companies of a similar nature built, but hopefully companies that do more good for the world.
Well, and with the same technology, you do go the biopharma route and find a massive industry using the same underlying biotechnology, and it just happens to be an easier problem to solve because there were lower hanging fruit with a bigger commercial need with everything from insulin to advanced antibodies.
And great profit margins.
Yeah, that helps too.
Materials, guys, materials. But you mentioned, Dan, that the sort of the search space argument on why nature is good to rely on. That still gives us really quite a few things we could be inspired by, right? Nature is, let's call it diverse, right? There's a lot of examples out there. How do you choose? How would one look at the problems and choose I've got just the thing for this, I'm going to be inspired by nature?
That's a really good question. There's no easy answer to that. We have not at Bolt figured out a way to go look at the world and say, oh my God, this one is so much worth it to go after rather than the billion other things we have on our list. I think what we found is, think of a Venn diagram that overlaps a capability in nature, understanding of the system that makes it, and a rough idea of applicability in terms of where it sits. So if you break the world into something like elastomers versus fibers, right? Okay, well, where would you want to start? And when we invent a new material, we've made thousands of them in the lab to kind of like prototype scale or like even material demo scale. We often find now we prefer to just make it cheap and easy to make them and test them and figure out what they're good for, rather than try to have a priori knowledge of what's going to be good, which turns out to always be a disaster. When you think you know something about the world, you're probably wrong.
I think that there is no solution, because this type of innovation comes when it comes. But there is a way to harvest somehow as much as possible out of innovation, or try to create innovation, or create a platform for innovation. And this is important in terms also of the education, and it comes really, I think, in the lab, in the research level, but also at the point that you really need to try to connect different disciplines and enable people with different background to understand what is happening, for example, in nature, and then how to harvest this lesson into an engineering process. So if you think about the example of silk, which is great, you need to have a good chemistry understanding on how the protein of silk make alpha or beta sheets. So you need to have good biochemistry understanding. Then you have to be a fiber engineer, because you want to be able to produce a material that has mechanical properties that are actually relevant in the industry. You need to be a textile expert, because then you want to somehow use these fibers into a commercial machine. So you see, you already are touching aspects that go from really the molecular level of the material to the biology of the organism to grow them, so biochemistry, to the final processing. So you have to create tools and a common language where people from the science to industry can translate the knowledge and create innovation.
Well, I mean, this speaks to your point, Dan, about it all seems very hard in the lab until you crack that and move on to the next thing. It's a common refrain about interdisciplinary pursuits of all sorts, right? Is getting people to have the common language that you're speaking about, and I guess also filling labs with the right kind of expertise. You've got to have a lot of different kinds of people around in companies like this. Do you have a problem sourcing? Do you have a problem the people pipeline at all?
So I'd put two points I'll make here. One, I totally agree, and I have a way to distill what one of my really smart people tells me. He's a Google X guy, used to run a big chunk of that, runs the nebulous title of Director of Special Projects, right?
Sounds cool.
He said when you don't know what he's optimizing for, he optimizes the pace at which he can learn and decide. And I think that's what this comes back to, is that when you're talking about so much depth. And that comes to like sourcing all good people to put in one room. And not more is better either. You don't always want more. You want high caliber, athletes who you can put together, who can solve problems in a nimble way. And so at Bolt, we don't have problems attracting people. Sometimes the right person who's perfect for the job doesn't exist in the world, and we have to build them.
Well, I guess that's what I meant by the question: is do you find that the world isn't creating the kinds of technologists, scientists, engineers that you need?
Well, no one's done this before.
I think this is a challenge that we have in education, in industry, in university, because sometimes people pick a specific topic in university because they really want to work on that topic. They want to be a chemist, they want to learn how to synthesize molecule, or they want to be biologists. They don't want to do any chemistry or maths, just want to observe nature. And, but this attitude somehow can be problematic, especially in this emerging field and technology where you really need to be able to communicate and to have a little bit broader understanding of, but you also need the deep understanding that the disciplines are able to provide. So it is a really, it is a challenge, I think. It's also in the point of view of education. How can you train the new generation of technologists to work in this type of companies?
Well, I guess what I'd say, I actually think most things are the same. And so, yeah, there's domain-specific expertise. Like, if you don't understand protein folding, it's probably going to be hard to work, but you can learn that. But, you know, the skills of critical thinking and really seeing the world are found in some people and not found in others. And some of the best scientists I've worked with at Ecovative, in fact, I would say they're our best, are artists. They started out as artists. They have masters in art. Maybe they started working actually in our production line because they thought what we were doing was cool, and they've ended up being some of the most insightful people we have who have made some of the best discoveries. So I definitely believe in what you're saying about building people. You know, you have to train for what your specific expertise is, but I definitely think that many humans are out there with the skills to flourish in this field.
But maybe not trained up specifically for something inherently multidisciplinary like this, but you find a way.
No, yeah, but that's changing, you know.
And I would say that when we think about people we bring in at Bolt, we found that the really high performers love finding people who are very different from themselves and learning from them, and that you want to build those little teams together, because what that happens is you're trying to build someone everyone acknowledges around the table that no one knows the answer. So the only way to do it is to know you're working with the smartest people in the world in their fields and work together to figure out what's the process to get to an answer. And it's maddeningly slow and sometimes has beautiful results.
You mentioned artists as sort of like able to see across this divide. I mean, in a sense, artists, you know, communicate across divides by nature, right? Communication, it strikes me, is kind of an important one for this field in the sense of, you know, at the consumer end, making sure people understand where it's coming from. Whenever life is involved, people get nervous, right? No spiders were harmed in the making of this, no mushrooms were harmed in the making of this, and so on. I mean, do you find that conveying the basis of the technology, the ultimate safety of the technology, the merits of the sort of nature, inspiration, and so on, you find that easy to get out to consumer level?
I think what I've found is as long as you talk about the benefits to the consumer, it's a much easier conversation. And it's hard, I think, as scientists or engineers to do that, actually, because what you want to talk about is like, this is how I made it, and this is why I'm really excited about how cool this process is. But what the consumer really wants to know is like, oh, great, I got a fabric that feels really good, and it's softer and stronger, right? You know, or I've got something that's going to last longer, or I've got an apple that doesn't turn brown when I cut it, so like my kids will eat it later, you know. So I think the history of engineering of organisms has been on the other side. The benefits are to the farmer, the chemical corporation. You can spray more Roundup on the crop and lower your prices. That's not a benefit to a consumer. So I think as these things do reach the consumer and they have tangible benefits for consumer, that communication gets a lot easier.
So I agree with that. On top of that, I think we've also found that transparency is key here. That, you know, we have from day one had a section on our website talking about how we view the technology we use, how we make it, and how it fits in the world. And I think we're probably a little unique out there in that what we sell, the organism that makes it, that does the spider silk, is not in the product. It's neutralized coming out of a factory-like setting. So it becomes, a material like any other you would buy. It was just made in a different way. I think we found as the benefit story takes over, people stop caring how it was made, actually. Now, if the organism was part of it, it might be a different story. I don't know. But for us, we've just been very transparent from day one.
You had any trouble conveying the merits and benefits?
No, I think I think the benefit, actually, people generally, as soon as they know that you work on natural material or bio-inspired material, there is a natural tendency to consumer to come. I think the only problem is that the technology that allows to benefit of this material they are still costly, right, at the end. So that's, I think, is the main challenge at the moment, to try really to produce them in a way that they are accessible to everybody. Because once they are, I think people will be willing to contribute.
How expensive is my sort of web slinger going to be when I get it?
Not as bad as you think. I think we think about startups in a couple of ways. Any new technology that's ever existed costs a good one costs a premium out of the gate because you're paying for the development. And I think it's a balance between price, cost, and benefit story on the other side. If it's an immense benefit, right? This is the pharma story again. Immense need, immense benefit. It drives an immense cost. I think over time, with access to scale, there's no reason biomaterials can't be as low as anything. I mean, we do pretty well on lumber and paper as biomaterials and the cost of those. But when we think about it, it's something we always want to drive towards, but we also want to continue adding new benefits over time. It's part of why we think of ourselves as a platform company.
Well, in that sense, it's sort of a question about scalability, and that's, of course, a consideration that kills lots of startups more generally. I guess the question is, do you guys here, thinking about the field more generally, do you see more progress, do you foresee more progress in sort of high margin, high value, but small volume, or vice versa?
I think the long-term potential is in mass market, the long-term, but all startups got to start somewhere at a premium price point. So I think they need to show outsized benefits in the short term to justify higher prices, higher margins, because if you're trying to support a capital structure that's often venture capital or transitionally based capital, you really need to have a high margin business, 50% or higher gross margins to support that kind of return that a fund is going to need. And I think most of us, when we start these companies, venture is where you end up because it's the capital source that's looking for ways to disrupt the world. That you really, starting in the niche and then going the mass market is a wise way to go.
Yeah, I mean, I think that's probably why you see a lot of these new materials entering in the fashion and apparel space, because it's quite possible to charge a premium for them and the benefit to the end user is so tangible. We at Ecovative took like a lot of hits because we launched in a commodity market and we launched and successfully commercialized a material to replace styrofoam and packaging. And as it turns out, people don't pay a lot of money for packaging, which I learned the hard way. And that really forced us to very aggressively move up a scale curve and a cost-cutting curve to catch up with an industry that probably was an expensive, styrofoam was a premium expensive material when it was created, but they had 60 years to take every penny out of the manufacturing process. And it's kind of unfortunate because I think some of these technologies with biomaterials can really address areas of real concern in terms of plastic pollution, environmental degradation, but they're all in this kind of tragedy of the commons buckets where there's no valuing of that value. And so it is a tension, and I think at the moment the right business model is to go luxury. Start luxury, pay your premium up front, and then walk down the value curve. But we may not have time for that.
I do have... Oh, go ahead.
Sorry. I think it's necessary that this type of new biomaterial enter in a massive way into the market. It's a necessity for the planet. So the main problem is implementing this in reality. And this also requires maybe some law that take into account what is the cost of actually producing plastic, right? And what is the cost in an environmental point of view? And what is the cost instead in approaching and using this new type of natural material? So this is something that I think it's really important. And so on a massive scale, but now we saw example, I think they are somehow specific or really high quality products that cannot be really mass produced, but we can also think about how this new technology, how can create markets that are not existing. So allowing material that can interact with the body, right? Because before we didn't have the possibility. So having material that actually improve our life, or they can substitute part of our sense. So all this new type of technology that is not existing, again, can be really high-end market, but at the moment it's not available.
Well, I mean, maybe that's the answer to the question about which problems do you choose, where in the search space do you start. Find those things that simply cannot be done any other way.
And I would add one more rule of thumb here when you're making that decision on productizing a technology, and this is what I tell a lot of young entrepreneurs, is You really want to find market spaces where the dynamic range of a comparable product is about 2 orders of magnitude, about 100-fold. So that you can find an entry-level thing versus the most premium thing, and it spans 100x price premium. Apparel is unique because it spans 4 orders of magnitude. I can walk down the street and show you guys where it goes from in the tens of thousands down to the single dollars. And that basically means there's going to be enough place to find that launchable point where you can make a profit and then bring it down market from there.
Okay. So more than 2 orders of magnitude is fine, just as long as you've got a lot of room to move.
Yeah.
Basically. And things that we can't get any other way. Is everybody taking notes here on getting your startup going? Yeah. We're running a bit short on time, so I wanted to ask you guys about the really long term, and really get your sort of imagination worked up here, because a lot of this, and we've already identified this continuum of, well, some of it is just looking at nature and trying to replicate it with, synthetic materials. Some of it is just basically piggyback on what nature is already making. There's a future beyond this that might include, wholesale, brand new, made-up life forms, right? There's a lot of push to that. Do you think that there's a lot of potential there? Do you think that's too fraught? Do you think that's the way this ought to go, will go? How do you feel about the ultimate expression of this, which is make life do our bidding?
Okay, I'll go first. I think there's a lot of potential there, but I think we're a long ways from that being the path of least resistance. I think there's so much we can do. As we said earlier, there's things from nature, and then there's humans looking at it and improving upon it. And there's a lot of pretty obvious ways to start putting things together and make life better and start replacing many of the materials on our planet that are not sustainable for the long term, that have massive externalities that are not baked into the price today. And I think as scientists and engineers, we often are more optimistic on our timelines than we should be. And so, well, I think that's a lot. If you're talking about hundreds of years in the future, yeah, there's probably a ton of potential there. In the next 1, 2, 3 decades, I think we're going to be overwhelmed with the things right in front of our faces.
I think it's somehow is what do you define a new living organism? Because when you engineer a bacteria to produce a new type of silk, that it's a new type of organism that wasn't existing before, right? The question is I think what it's really different and what it changes, when this organism can start to interact independently from you out of the lab, when they can create an ecosystem. So this is, I think it's the understanding of ecosystems and how can you then release a species to produce something that it's really far, because also the understanding in terms of the point of view of research is how different colony of bacteria interact, how symbiotic processes work in nature, also in ourselves, right? It's really hot topic in the science, but I think that's one of the vision that has to be for the future.
Big future?
Yeah, I'm super biased on this. I think the answer is absolutely yes. I think materials that are alive and objects that are alive is going to be the ultimate extension of everything we're doing. I'm probably a little more bullish on timeline than you are. I think we're going to be limited more by rules in society than where the technology takes us. And I'll end with a quote by R.J. Kirk, who's the CEO of Intrexon, which is a big industrial biotech conglomerate trying to bring these technologies to consumers. And what he points out is that humans are actually technology too, and we forget that. And so,
and chickens, I like.
So I use chickens. People are a little more comfortable with that. You don't want to hear you're like a wet, squishy robot at a conference, but surprise. Mm-hmm. But yeah, so I think it's coming. It's going to happen, and I think it will be good for the Earth.
Right. Well, that's it then. But let me thank you first, myself, Silvia, Dan, Eben. Thanks very much for your time, and you guys, thank these people.